So today we're looking at formulas we're going to use with constant acceleration. So you should have a copy of your formula sheet. If you click here, you'll get a copy of your formula sheet, and that will show you all the formulas we're going to use for forces in motion. And we're going to key in on these highlighted ones right here. We've already looked at these two for velocity and acceleration. Now we're going to look at each of these formulas. So if you haven't already taken a second to print that formula sheet, make sure you have it printed and kept somewhere. You need it for all assignments and exams. Okay, so this is the first one I'm going to look at. Displacement is equal to the initial velocity times time plus 1/2 acceleration time squared. Okay, so here's an example of a problem we're going to do where we use this formula. Whenever we start a question, we're going to write down everything we know, the known information, and that's going to help us determine which formula to use. So you're flying this jet at 97 meters per second, so that would be your initial velocity. I accelerate at 26 meters per second squared. All of these are positive, so that's telling us it's all in the same direction. And my time is 12.3 seconds. How far did you drive? Did you drive? Sorry, fly. So displacement is what we're looking for. So I need some sort of formula that has displacement, an initial velocity, acceleration, and time. Yep, I have all those things, and that will give me displacement. So that tells me this is the formula that I'm using. So displacement equals initial velocity, which we said was 97 meters per second squared, times the time, which is 12.3 seconds, plus, this is just from the formula, sorry, first of all I should really write out the formula that I'm using. That would be good physics way to answer a question. This also helps me when I'm correcting, so I see where you fell apart. Sometimes I'll see that all you had was a copying error, you forgot to square something. It really helps me to find out how to fix a problem as well. Also, if you make a mistake, it's best to have it all written down so you can check it. Okay, it is equal to 1/2, or 0.5, 1/2 acceleration. We said the acceleration was 26 meters per second squared times 12.3 squared meters seconds squared. Okay, before I put this all in my calculator, I want to do this all in one step in my calculator. I'm going to check out my units here. So I have displacement. So I should already be thinking about what unit I want this to be when it's done. Here I have meters per second times second. My seconds cancel out. So I have meters plus, over here I have meters per second squared times by second squared. I'm going to have meters plus meters. In other words, my final answer is going to be in meters. Displacement is in meters, so I probably have done this correctly. I've probably set it up correctly. Okay, I want you to put this entire thing into your calculator. I don't want you just to watch me do this. I want you to have your calculator and do this at the same time. That's going to ensure you can do this on an assignment or a test. So press pause if you need to, put it in your calculator. When it's all said and done, you should get 3159.87 meters. Now, significant digits. It looks like I can only have 2 significant digits. Okay, so with 2 significant digits, that would mean it's 32, because I'm rounding here, 00 meters. So this would be best to put in scientific notation to show that these are not significant. 3.2 times 10 to the 1, 2, 3, 10 to the 3 meters. And that is my final answer.